In this lesson, we'll be looking at the question, can we manipulate inequalities with multiplication and division like we manipulate equations?
So as you may have noticed while completing the table, when we multiply and divide with inequalities, it's not quite the same thing as equations, and we do have to be careful about a few things. For example, let's take a look at this problem here. I've basically created an inequality that is a true statement. 10 is less than 20. And when it comes to multiplication division, there are certain things I can do and the inequality stays true, but then there are some cases where we do have to be careful because things get switched around. Let's start off by, let's say, dividing both of these by 2. I'm going to divide one side by 2, divide the other side by 2, in which case we would get 5 and 10, and they're still less than. 5 is less than 10. So dividing by 2, no difference. What if we multiplied by 3? Multiply this side by 3, multiply that side by 3. We get on this side 15, on this side 30. And our inequality still remains true. 15 is less than 30. All right, let's keep going with a few others. Let's take this one, put it right here. And let's say we took these and divided by, in this case, let's do -5. Well, here's where we have to be careful. In this case, 15 divided by -5 is -3. 30 divided by -5 is -6. But -3 is not less than -6. In fact, what's happened is our values have kind of flip-flopped. Positives became negatives, but because of the nature of negatives and greater than and less than, -3 is actually greater than -6. So in order to make things true still, we have to flip-flop the inequality the opposite direction. Let's take a look at one more. Let's multiply both sides by, again, let's use a negative. -2. If I multiply this side by -2, my -3 becomes +6. -6 times -2, my -6 becomes 12, positive. Now again, these two are no longer greater, 6 is no longer greater than 12 because the negatives and positives have reversed. And so once again, to keep this a true statement, I have to flip around the inequality symbol to make it still be true. So basically what we're saying here is that when you multiply or divide with inequalities, you have to be careful when multiplying or dividing by a negative, which will kind of sum it all up in this next slide.
Alright, so let's take a look at this problem. -6y is less than or equal to 90. And in this case, we're trying to solve for y and then graph the answer. Now in this case, -6 times y means we need to just undo it, so the opposite of timesing by -6 would be to divide by -6. What I do to one side, I do to the other. Now, just like we talked about, what happens here is that the times by -6 divided by -6 cancels. We get y. 90 divided by -6 is -15. But because we divided by a negative number, what happens is positives became negatives, negatives became positives, and everything reversed. So what that means we need to do is anytime we divide by a negative, we need to flip the inequality symbol the other direction. So in this case, a greater than or equal to symbol. That way everything still remains true. Alright, now let's take a look at the graph. let's get our number line up here. In this case, I just went by 5s because I want to go all the way down to negative 15. Y is greater than negative 15, which would be all the numbers on this side, and then y is equal to negative 15. So it means I want to start at negative 15 and include negative 15, so a closed dot, and then everything greater than that would be to the right. And that's how you solve the inequality negative 6y is less than or equal to 90. Alright, so let's try this next problem. 4/3 times m is less than 6. So as before, we want to undo this inequality and get m by itself. So here we need to get rid of this times 4/3. Now normally the opposite of timesing would be to divide.